Hey, and welcome to my AutoGen course. And AutoGen is a multi-agent framework. And if you have no idea what I just said, that's okay because I explained everything from the beginning. But if you do know, or you have worked with AI agents before or another multi-agent framework, then maybe some of this will be a refresher and hopefully I can teach you something new. We have a lot of topics to cover and code, and we have a few projects as well. A couple of the projects I ask you to do, so you can pause, try to complete the project, and then when you unpause, I'll show you what I did. By the time you're done this course, you'll know what AutoGen is and be able to code your own multi-agent workflow. Well, we got a lot to do, so let's get started. Well, what is AutoGen? Well, it's an open source multi-agent framework that has almost 25,000 stars on GitHub, averages 40,000 downloads a week, and was recently mentioned in Andrew Ng's PowerPoint at Sequoia Capital's AI Ascent in a citation. It offers many possibilities and even more than I can list here, such as function calling, group agent chats, teaching your agents, multimodal integration, and more. But first, if this is your first time talking or hearing about multi-agent framework, or maybe you just need a recap, let's quickly look at something that you probably do know, ChatGPT. If you went to ChatGPT, you would ask it to write something. So here, I'm just asking it to write a Python function that reverses a string. Pretty simple, pretty straightforward. And this is what's called my prompt. Then it would give me a response, or what's called a completion with some code. It would normally give you a description of how the code works as well. This is like having a single AI agent and talking to it asking for help. So if this represents a single agent, then in a multi-agent framework, this means we could have more than one of these agents talk to each other to solve problems. Here we can see examples such as a three-way chat or even a hierarchical chat pattern. That's where one AI agent will talk in turn to other agents to solve a problem. In this simple two-way conversation, we have a user agent talking to an assistant agent where the user agent can represent you or me. We would ask the AI assistant agent to plot a chart of Meta and Tesla stock price changes year to date. The assistant would come up with some code, their user agent will try executing it and maybe come up with some errors, and then if there are, it'll give that error back to the assistant to fix, and then we'll keep going through this process until the problem is solved or to your liking. We will start off performing a two-way chat and coding it before we get into multiple agents so you understand the code and how this works. We're going to create a user agent, an AI assistant agent, give a configuration to the AI assistant agent, meaning we will connect it to OpenAI's API and then run it to see the output. Later on in this tutorial, we will see how to use local models, which means if your hardware can handle it, you can download models and run them for free without paying the price of OpenAI's API. We're going to create a con environment, even though you are more than welcome to create a virtual environment. We're going to install PyAutogen. And if you're asking, why aren't we installing AutoGen? Well, that's simply because the library for just the name Autogen is already taken, and that's for something completely different. So they had to rename it PY Autogen. We're going to create the configurations to connect to the model, create the agents, and then finally start the chat. Let's get started. Okay, well, the first thing is if you don't have an IDE, which stands for Integrated Development Environment, which basically means we are going to be running software to help us create software. I would choose PyCharm, especially if you're kind of new to this, you're not used to creating environments. This is going to make that easier for us. Now, you can pay for the professional version, but I don't like to pay for anything as much as possible or make it very cheap. So instead, I'll have this link in the description and you can download the PyCharm Community Edition, which is the free version. So you just click this download for your machine and then open it up when you're ready. Okay, and once it's opened, you probably won't have any projects if this is the first time you're downloading it. But if you do, regardless, you'll see some lists like this that I have here. If this is your first time downloading this, you won't have any projects here. So you can go ahead and click on create new project. I'm going to name this AutoGen Beginner Tutorial. You can choose your environment here. So you can choose Conda or virtual environment, whichever one you want. I'm going to choose Conda. I'm going to choose the Python version. As of this tutorial, I'm just going to use 3.11. And you don't need to choose to create a main PY script because we'll be creating all the Python files anyways. And then just go ahead and click create. And it's going to go through the process of creating the environment for us. All right, so here is our screen. Now I'm going to go ahead and create a new directory under this project. So right click, new directory, and we'll just name this O1 two-way chat. I'm also going to have this project in the description. So if you get lost at any point, you can just go ahead and retrieve the files from there. Now go ahead and right click on that new directory and choose Python file. And we'll just name this main.py. Okay, and now we're ready to code our first AutoGen application. And before we do this, we need to install the Python package like I mentioned. So in PyCharm, if you open up your terminal down the left-hand side here, click this, and then you can just say pip install PyAutogen. Once that is done, just minimize the terminal window and we can begin. The first thing we need to do is import Autogen. Now, as we go, I'm going to show you multiple ways to do different things. So the first thing we're going to do is create a main function. So we'll say define main colon, and then get ready to include all of our agents. Now, the first thing that I do for pretty much every, and that you'll do for pretty much every AutoGen application is you need a config list. Say config underscore list equals AutoGen dot config list from JSON. And what this function does is it retrieves a separate configuration outside of this main Python file and then brings that in here for us to use. And we'll create that file in just a second. And we can say env or file is equal to oai config underscore list dot JSON. Now what this is going to do is going to bring all the information from a JSON file or all the properties from there so that we can use it for the configuration of our AI assistant and connect to the model. Just right click on the two-way chat directory, click on file and type in oai config underscore list.json. Now I'm just going to copy this in here, but you can have an array of JSON objects so that we can retrieve the model and the API key for OpenAI. The model we'll be using is GPT 3.5 Turbo, and you need an API key. So let me show you how to get that key. You'll go to platform.openai.com. Once you're here, at the top right, you can choose login. If you haven't created a login, go ahead and sign up now. It's free. Once you've logged in, on the left-hand side, go to settings. You go to billing. And as you can see, I already had put a few dollars in here before. So I have a credit balance to use the GPT family of large language models. Now, for you to use this, I would say just give it like a couple dollars, right? Because we're going to be using the 3.5 Turbo model for most of this until we get to the local model usage, and it's really cheap to use that model. So once you just add a couple dollars here, you'll go to your API keys on the left-hand side, and then you create a new secret key. So beginner tutorial. You'll create a secret key, and then you can copy this. So once you copy this, you'll simply just put it right here. Now, the next thing to do is to create our two assistant agents. We'll say assistant equals autogen dot assistant agent. We need a couple parameters here. We're going to say name equals, we'll just say assistant. And then we have an LLM config property. And this is important for any assistant agents. So you say LLM config is equal to. Now for other projects, I'll create a separate LLM config to put here. But for now, what we need to do is need open brackets and we need a config list property. So we say config list colon, and then we'll give it the config list that we just created above. Now the assistant will know to connect to the 3.5 Turbo model with OpenAI with our API key. And then we need our user proxy agent. So user underscore proxy is equal to autogen.user proxy agent. And so we need a name. We can just say name equals user. And then we need a code execution config. Now, any code that the user proxy executes that it gets from the assistant agent, we can have it save it to a directory in our project. So we can give curly braces, and then we say work underscore directory, or just dir, and then we can just call it coding. And then another important property, if you do this, you'll say use Docker, and then we'll set this to false. So if you have Docker and you know how to use it and you have it running, then you can just set this to true, or it's true by default. However, if you don't have Docker or you're not really sure what it is, make sure you set this to false or it will not run. Okay, that covers almost everything we did except for starting the chat. So we'll come down here and we'll say user proxy dot initiate chat. We want to initiate chat with the assistant. And now we need to tell the AI agent to do something. So we're going to say message equals plot a chart of Meta and Tesla stock price change. And there's one more property with the user proxy agent that I want to show you. So after name, doesn't really matter where, but after name, type in human input mode. And what this allows us to do is either be a part of the chat with the AI assistant, or we can say we never want to be a part of it and then just let the user proxy agent and the assistant talk to each other, execute the code, and just let them handle it themselves. And that's what we're going to do. So you're going to type in quotes, never, and then comma. And then finally, we're going to say if name equals main, just run the main method. Okay, well, we finished with that. Now let's just run this. So if you just click the green arrow here, or you can do it at the top. Okay, so the user initiated the chat with the assistant right here. So we asked plot a chart of Meta and Tesla stock price change. So the assistant to the user came back and said, hey, here's a step-by-step guide. Let's start with historical stock price data, and these triple backticks in Python, this means that this is code that it's going to run. And when you see a hashtag followed by a file name, this is the file name it should save it in your directory. So here it's creating the code. It created all this code, and now it's going to go back to the user, and the user is going to try to run this. But as you can see, it did, and I got X code of 1 because we don't have the pandas library. So then the assistant creates a shell script to install the libraries that we need. So it did that. The user then executed that, started installing all of these libraries for us. And then the assistant said, okay, now that you have the required libraries, you should be able to run this. And then finally we terminate. Now on your end, it may show up with the graph automatically and it may just run. However, it just did for us, and that's fine because this can be different iterations of the code. Yours might be different than mine. So if we minimize this, you can see over here in the directory, it created a coding working directory and it created the stock price chart Python file. But you can see here, it saved the code that the AI assistant wrote. Awesome, we just had our first AutoGen application work. All right, now what if we did want to interact with the AI assistant and maybe wanted to change it at some point? Well, in order to do that, you can do one of two things. So with the user proxy agent, in the human input mode where we put never, there's two other options here, always and terminate. If we say always, this means that at every time that the AI assistant gets done something, we can either say, hey, okay, that's good, but maybe add this or remove that. And then we press enter and it'll do something else. Or this can say terminate. And what that means is that whenever we're about to terminate, meaning that all the assistants or all the agents think that they're done, before we actually terminate, we can say, hey, you know what? I want you to try this instead. So let's test that. Now just change this to terminate and run this again. Okay, and actually look at that. I didn't even have to make an API key and it went ahead and created a graph for us from the same code that we used. So if I exit this, now when the assistant said terminate, now we have the chance to give feedback to the assistant. Well, how about this time instead of Meta, I want to say NVIDIA and Tesla are the two stocks that I want to compare. So instead, compare NVIDIA and Tesla. Press enter. Now, us as the user are going to tell the AI assistant the same message. Instead, compare NVIDIA and Tesla. Now the assistant is going to modify things and execute the new code. And as you can see, it changed from Meta to NVIDIA versus Tesla stock price change. Now that we were good with that, we can just say exit. And we are done. But instead of terminate, what if we say always? We run this again. Now what happened is we, the user, told the assistants to plot a chart of Meta and Tesla. The assistant came back with the same code and told us what it was going to do, but we are already able to give feedback. And what this means is every time the user gives a task to the assistant agent and the assistant agent gives some code or whatever it does and gives it back to the user, now we are able to provide feedback or intervene into the conversation. And so every time the assistant does something, we as the user are allowed to say, hey, you know what, actually, instead of Meta, do NVIDIA or Apple or whatever you want to do. It doesn't need to be stock price change. It could be a percentage. And this is how we can be a part of the chat if we wish to. Now, great. This is basically doing something like you would with ChatGPT, just one-to-one chat interaction. Now let's take a look at group chat. Well, this means we can have multiple AI assistant agents talk to each other and each have their own task or job to execute. Let's say we want to plan out and give more direction to each agent. We can have a planner agent, engineer, a critic for the code, and a separate agent to execute the code to test. This time, we will just create more agents and have a group chat and a manager for the group chat. Then we initiate the chat and let all the agents come up with a plan to solve the problem. Let's code this. All right, so because this is a lot of code, I'm just going to paste this in. I'm going to go through it. There are some new things here, so I'm going to make sure I go through those so that you understand it. But this will be on my GitHub if you want to follow along. Now, the first thing we need to do is import AutoGen and .env. .env is a library that allows us to take a .env file with some properties and then add them into the config list for AutoGen. So in the previous one, we created a JSON file. In this one, we're creating a .env file, and this is just another way. So to do that, we have to load .env first so that it can look for this .env file and then get the properties from there. So we'll say config list equals autogen.configlist from .env, which is just a function for AutoGen. We want to look at the .env file. And then for the 3.5 turbo model, we want to look for the OpenAI API key in the .env file. If you right click on group chat, go to new, then you'll type in .env and create the file. Okay, and when you open that up, you'll type in openai underscore API underscore key and put your API key here. And now we can connect to the 3.5 turbo model with our API key. We have an LLM config with a few properties that are kind of new here. So the first one is the cache seed. Now, when we ran the two-way chat, you see that there's a .cache folder. That means if we ran the main Python file again and didn't change anything, we're going to get the same exact result because it cached that for us. And if you open up the .cache directory, there's a directory called 41, and 41 is the default cache seed it always used if you don't give it a seed number. And there's a cache database where it stores all the information about the whole inference that you had, which it means from the prompt to all the results. And it has that stored in this database that you can look at. So if you want a different outcome, you can change this seed to any different number every time, or you can just type in none and you'll always get a different outcome every time. So the temperature is set to 0 because we want to do exactly what we ask it to. Then we have the config list property, which is the needed one for the LLM config. And then we have a timeout that comes in seconds. So 120 is just 2 minutes. Okay, and then we have our user proxy agent, which we created before. And we have the system message, the name for it, the code execution config means that when it goes to execute code, it should save that code into a code directory. So here in the group chat, there should be another directory once we run this with the Python file in it. And I set the human input mode to terminate because I don't want to intervene until the end and I want to know if it works. Okay, and then we have 4 assistant agents. We have an engineer, scientist, planner, and a critic, and they all have their role, and they know their role by having the system message, so they're going to follow a description or a plan of what I kind of want them to do. So for instance, for the engineer, I want you to follow the approved plan, probably from the planner, and then make sure you save the code to disk and you write Python and shell code. Okay, so with these system messages, it gives a little bit more direction for the assistant agents. And then finally, something also kind of new is the group chat that I talked about. So you're gonna say autogen.groupchat, then you're gonna have an array of agents. So we're gonna give all of the agents here that we just created. And we're gonna set a max round of 12, meaning that sometimes you can kind of get loops and it just kind of, they talk to each other, but they don't actually do anything. And this is a way of making sure that, okay, if that kind of happens, kind of this like infinite loop, that is going to end at some point no matter what. When we create the group chat, we actually need a group chat manager, which takes in that group chat and an LLM config. And finally, we say user proxy.initiate with the manager. And then we give it a message. And this time we want to find papers on LLM applications in the last week and create a markdown table of the different domains. Okay, now let's run this and see how it works. You can just right click on the main Python file, go down and select run. Okay, so let's see what happened here. So I asked it to find papers on the LLM applications and create a markdown table. So the planner first went in the group chat. It went ahead and created a plan for everybody. Then the critic had some feedback for the plan, and then the engineer started creating the code. Okay, so the engineer here created see this file normally means that it's going to create this file in the directory for you under the working directory that you provide. So it created all this code. And then the critic comes and takes over the plan, and the scientist also looks at the plan and kind of get the same error here. The same code output is like, hey, the string indice needs to be an integer, not a string. So it tries to fix it, and finally it ends the chat. Now, I know what you're thinking. This didn't work at all, and you wouldn't be incorrect by saying that. And this is probably because I had the max round set to 12, or it would have continued to try and fix the code and revise it and so forth. And because it didn't actually finish, at the end, it didn't save this to the code directory here. And that's okay. This is actually a good representation because, not everything works every time that you want it to. It's just, it's part of this. Maybe if you try GPT-4, it can give you a correct output. I mean, it's given me correct output for this. I mean, I've done this many times, and it has given me 3.5 turbo typically gives me the correct output. But if you wanted to run this again, see, it already cached. We have the cache seed of 41. If you want to run this again, try with a different cache seed and see what it gives you. All right, so for the first project of this tutorial, I want you to try something. I want you to try to create a snake game. So the steps that I would take were, besides having a new directory, create a snake.py file, create a new config.json file, create a user agent, and then a group chat. Make sure at least one of the agents is a coder, and maybe you want to have somebody playing something, or maybe you have some like a critic that says, hey, that is not a good game, do better. And then come up with the prompt to create a snake game. Go ahead and try this on your own. Whenever you're done, press play again on this video, and then I'll show you what I did. Well, this isn't exactly the snake game that I asked for, but I got it. There's no apple or any red dot, and I just don't die. Perfect. Okay, so I hope that you figured something out, that you got something running, and I hope that it actually gave you a snake game. In a couple iterations, it did for me, and as you just saw, this was my latest iteration. That was not snake. I don't know what that was, but it wasn't snake. So what I did was I created a new project for o3-snake, created a main Python file and my oai config list.json. In my main Python file, I just have the config list here. I have the LLM config. See, I had to change the cache to 47 because I tried this a few times. I have a user proxy agent with a simple system message. And actually, this doesn't do anything. I'll show you how to make sure that it saves or has a better chance of saving the file to the disk. The human input mode I set to never because I just want to see what it would do. And then I have my code execution config. And then I had two other assistant agents. I had a coder, and this is, if I were you, I would copy this and kind of anywhere you want to make sure that it saves code, because as you've seen, it doesn't always save the code. But if you had this line where you say, if you want the user to save the code in a file before executing it, put hashtag space and then the file name and the name of the file inside the code block as the first line. And then that will help ensure that it actually saves the code. And then I have a product manager just to help plan out to create the games, right? I create a group chat with the user proxy, the coder, and the product manager. I create a group chat manager. And then finally, I said user proxy.initiate chat with the manager. And then the message is, I would like to create a snake game in Python. Make sure the player hits the side of the screen and ends the game. Okay, so after I did a different iteration, I ended up getting an actual snake game. I suck. So that's okay. That's another issue. But either way, so this took me more than one iteration to try and get it to work, and that's okay. And you can also play around with different models to see what works best for you. All right. Well, so far we talked about a couple ways that we can chat with agents. We have a two-way chat where we have a user agent and some AI assistant talk to each other to produce an output. And we've had a group chat where we have a user initiate chat with a bunch of agents and they all talk to each other to perform a task or solve a problem. Well, there are a couple other ways that could make more sense depending on the needs for your project. But with something called a sequential chat, we can have agents work in a specific order that we want. Meaning, if we have three agents, we can initiate a chat with agent one, then with agent two, and then finally with agent three. This works by essentially having an array of chats. What happens with this is the user agent will initiate a chat with the first assistant agent, and then when they're done, the user agent will initiate a chat with the next, and so on. What we can do though is for each other chat in the sequence, we can send context from the previous one to the next. And this is called reflection with LLM. And this will summarize the previous output and bring it to the next agent. Let's see how this is done with code. Okay, back in our project, the first thing we're going to do is create a new directory called this sequence chat. I'm going to create a new Python file called main and create a new file called oai config underscore list.json. For the config list.json, let's go ahead and put in our model and API key. So you'll just switch this with your API key. Okay, now for the main Python file, I pasted some of the code here, but I'm also going to type some of this with you when we get to the sequential part. So like always, import AutoGen, create a config list, and I have something new here called filtered dictionary. This means that if you can have, remember, this is an array, so you can have more than one of these, right? So I could copy this, put comma, and paste, and this model could be GPT-4. Well, if I just send this to the main Python file and I didn't have this filtered dictionary there, then this would just grab the first one, so it would just grab 3.5 turbo anyways. But if I wanted to use, like say GPT-4, then I would have to put in here GPT-4, then it filters out from this array which one or which properties or configuration that you want to use. So in this case, it would look at this one, look at the model GPT-4, and then also get the API key from it. So I just want to use 3.5 turbo, so I'm just going to keep that there. And this is just another way that you can use the configuration. I had the LLM config, the config list, and the timeout. Okay, now I have three assistant agents, right? I have assistant quote one, where you are an assistant agent who just gives quotes, return terminate when the task is done. And I basically copy and pasted that to the second assistant quote, who this is somebody who will give another quote. And then I have the third assistant agent who is going to create a new quote based on others, which means that I'll give the context or what the output was from the first two and add it to this assistant agent so they can create a brand new one. Another property here is the max consecutive auto reply. I just set it to 1, meaning once they come up with a quote, I don't need them to do anything else, right? This is just a simple task. And then finally, I have the user proxy agent, and I do have a new property here. It's the is termination message. So you can create a lambda where it checks if the content is not none and if terminate exists in the content. And this means that we will now terminate the chat. Okay, now for the sequential part. We're used to saying user proxy dot initiate chat and then giving like one of the assistants. So for instance, assistant quote 2, and then we can give a message. However, it's not quite like that. What we're going to do is instead say user proxy dot initiate chats, just with the capital S or with another S, not a capital. And then this is now a different function. And inside of here, you want to create an array of chats. So then we have a dictionary, and the first property is the recipient. And the first assistant that I want to go in the sequential order is assistant underscore quote 1. The message is the next property, and I want to say give a quote from a famous author. If I can spell. Then the next property is clear underscore history. Set that to true. The next one is silent. Set that to false. And all silent means is that if this was set to true, you wouldn't really see the chat conversation. You would just see just the output and that's it. But with false, we get to see everything. And then finally, there is another one called summary underscore method. And this is where we're going to set the reflection with LLM. And again, what that means is there's two ways. You can do last message or reflection with LLM. So reflection with LLM will take the whole chat conversation that the user agent is going to have with assistant quote 1, and it's going to summarize that. The last method will just get just the last message that was in the chat. And what I'm going to do now is just copy and paste this 2 more times because we have a total of 3 agents. Okay, so I know that the second one is assistant quote 2. I'm going to say give another quote from a famous author. And then for the third recipient, this is going to be assistant create new. So I want the first one to get a quote, the second one to get another quote, and then the third one, I want to create a brand new one. So for the message here, we'll say, based on the previous quotes, come up with your own. Okay, and that's it. Now we're done. Also, with PyCharm, it gives you the squiggly lines here. This is just saying that you can reformat the file. Okay, and now the last thing we need to do is just run it. Okay, see, it's already doing a lot, so let's just start from the top. Okay, so we start a new chat. The user proxy talks to the first assistant. Give a quote from a famous author. Assistant 1 returns, don't cry because it's over, smile because it happened, from Dr. Seuss. Perfect, and then it terminates. So now that's done, and we're starting a new chat. So the user proxy starting a new chat with assistant 2 saying give a quote from a famous author. Give another quote from a famous author. But the context is the quote provided is from Dr. Seuss and emphasizes the importance of cherishing memories. All right. Sometimes it gives you the exact quote, or because I have it saying summarize, this is just what it gives you. All right. So now it gives another quote saying the only limits for tomorrow are the doubts we have today. Okay, and then it's done. And now finally, we start our third chat. Based on the previous quotes, come up with your own. And the context is taking the summary from the first 2 and adding it here. And so now it's going to create its own. In the tapestry of life, cherish the threads of memories and weave them with threads of positivity. Perfect. And then finally, we're done. So this is how we can sequentially tell our agents to do or perform a task in a specific order. The last way we dealt with chatting was sequential chats. Now we're going to look at another way called nested chat. What this means is when an agent is done with a response, we can have a nested chat separate from this chat chain. Let's look at this example. Here, the user tells the writer to come up with a simple blog post about Meta. The writer does, and then sends that back to the user. Normal chat. But now we have a trigger on the writer, meaning when the writer is done, we can start a new nested chat. So for this example, we have one nested agent, that's the critic agent. So when the user talks to the writer will send a response back to the user agent. Now that we have in our code a trigger for the writer to start a nested chat, the user will then take what the writer wrote, send that to the critic, and then the critic will then respond back to the user agent. And then we can kind of keep this repeatable loop going on until we are good with the overall result. So you might be asking, well, what's really the difference between this and then just adding a critic into the group chat? Well, nested chats are a sequence of chats created by the receiver agent after receiving a message from the sender, and finished before the receiver agent replies. So what this does, it allows AutoGen agents to use other agents as their inner monologue to accomplish tasks. This kind of gives it like an abstraction. Let's just look at how this is done in code. All right, well, back in our IDE, go ahead and click on our project, create a new directory. You can call this 05 nested chats. Right click that directory and create a new Python file and just call it main. And we'll also create a new openai config underscore list.json file. This is going to be a little repetitive. I understand we've done this a few times already. So what you could do is you could just go up to a previous directory and copy paste that config list into this new one. Okay, so I just copy pasted this code and I'll just kind of run through it again. And I'll show you the difference at the end on how we deal with nested chatting because I said there's a trigger. So we import AutoGen, create our config list based on the JSON file that we just created. Then we create our LLM config given the config list. Our task, so we're just gonna have a separate variable for our task, which is to write a concise but engaging blog post about Meta. And we had 3 agents that we talked about. So we have the writer agent, where you give the name, LLM config, and a system message. Then we have a user proxy agent, which is typical. Then we have the critic agent. Okay, and we said the critic is what's going to be once the writer responds, then the critic is going to be triggered. Okay, and then what I have here is a reflection message function. Takes in 4 different parameters. You'll know when this is triggered because I have a print statement called reflecting so that we can see this. And it's going to return reflect and provide critique on the following writing. Essentially what we're doing is we're getting the last message from the sender. Okay, that's what sender -1 with the content. That means we're going to get the last message from the sender. And then what we have, it was a user proxy.register nested chats. We have to register the nested chat and we had to have a trigger for it, know when we want it to start up. So we have an array here, so you could have multiple recipients with multiple messages here. Right now we just need one. So the recipient is the critic, okay? So this is the critic. The message is going to be this function up here. The summary message is the last message and max turns of 1. And then we have the trigger, which is the writer. Okay, this is how we'll know whenever the critic is going to start because it happens whenever the writer has a response. This will make more sense whenever we look at the output. And then we say user proxy.initiate chat. The recipient is the writer. The message is the task. And I'm just going to say max turns of 2 so that we can see that the user proxy will talk to the writer and then the critic. So let's go ahead and run the main.py function. Just right click main and choose run. Okay, so we're going to say user to the writer, write a concise but engaging blog post about Meta. Then from the writer to the writer responds back with a blog post and a title about Meta. And then we start the reflection. Okay, this means that we're going to start a new chat. So the user isn't going to respond to the writer. The user is going to respond to the critic now because the trigger was the writer. So the user talks to the critic. So it's reflect and provide critique on the following writing. And this is just the last response from the writer. Then the critic takes that, critiques it, sends it back to the user, and then the user goes back to the writer, says, the writing presents blah, blah, blah. Here are 5 things. And then in conclusion, writing effectively about Meta and the metaverse, incorporate some other things. Okay. And then the writer takes the critique, modifies what it originally wrote, and then sends that back to the user. So again, because the user talked to the writer back to the user, because this writer, it gave the response that triggered the nested chat. So now the user starts talking to the critic. Now, if we had a sequential nested chat, then we would have the user talk to the critic and then all of those other agents before it got back to the writer. I know that this was a little bit of a different concept, and I have another video already about how sequential nested chats will work. So just give this a try. See what you can do with it and let me know how it works for you. Today, I'm going to show you AutoGen logging. Now, you might be asking, how can this help me and what can it be used for? Well, we can take a look at performance analysis of the LLM calls. We can see how long it took the chat to complete, how many tokens did we use, what was the cost, unless you're using open source local LLMs, and we can simply log the response. Well, how it works is we'll start the log before we initiate the chat for AutoGen, and then after it's over, then we'll simply call it to stop the log. And then what happens is stores this performance analysis into a database for us. Well, let's see how it looks in code. The first thing we're going to do is call autogen.runtimelogging.start. And for the configuration, we're just going to give a DB name. Here I give it logs.db. And then we'll have some initiate chat logic. and then we'll call autogen.runtimelogging.stop. After that's done, it's going to create a logs.db for me if I haven't ran this already, and then insert the rows of data. And then we can retrieve this data and see the performance analysis of our calls. One way to do that is to use SQLite Browser. This is a free software where all you need to do is open up your database in the software, and then you can see all the tables and then all of the rows of data for each table inside of your database. And here, for instance, the cost of 0.0 is whenever I use GPT 3.5 Turbo. It's not exactly free, it just is very minimal cents. And then between the 2 and 3 cents range, that's when I use GPT-4. So you can see the cost increase. Another way is to install the pandas library, and then we can retrieve the data how we want and make it look nice in our terminal. I think this would be particularly useful for open source local LLMs, and so we can decide which one was the quick to finish the task, which one used the least number of tokens, and which one gave us the better responses. Well, let's get into the code and look at some examples. All right, well, the first thing we need to do is create two files. We're going to create a main Python file and then the openai configless JSON file to hold our model and API key. You could also use this to store the base URL if you're using open source local LLMs. So over on the configless JSON file, I just simply have the model I'm going to use, and then you would insert your API key here. And if you're using a base URL or something like LM Studio, you could also paste that here. And now back in our main Python file, the first thing we need to do is set up our imports, which means that we also now need to install them. We just need to open up our terminal and then type in pip install pyautogen and pandas. And now we need to create the LLM config for the assistant agent. We really only need the configlist property here, which is calling autogen.configlist from JSON, and give it the openai configlist JSON file we created earlier. And what this is going to do is get the model and the API key that we stored in there. And then that'll later be used for the LLM call. And now we can start our logging. So we're going to call autogen runtime logging.start. And for the configuration, like I showed in the PowerPoint slide, we're going to give it a DB name and call it logs.db. Over here in my autogen logging directory where this file is, I don't have a logs.db. It will create this for us automatically whenever it's done. And then for this simple example, I'm just going to have an assistant agent, which I pass in the name and the LLM config that we created above. For the user proxy agent, we give it a name. We don't really want it to execute any code because in this case, we're just going to ask it a question. The human input mode is never, because I'm not going to talk back and forth with the LLM call. Whatever happens, that's what we're going to use. And then we just have a simple termination message. Then we say user proxy.initiate chat with the assistant, and the message is going to be what is the height of the Sears Tower. Only respond with the answer and then terminate. And then after initiate chat's over, we just simply call autogen.runtimelogging.stop to end the logging. And now you could stop here and you can skip ahead to where I talk about SQLite Browser, but I'm going to show you the code to use pandas so we can see it in the terminal. What I'm first going to do is just have a function to get the logs. I'm going to pass in the DB name. By default, it's going to be logs.db that we are going to be creating. And then there are several tables in there, but the one we care about is chat completions. I'm going to use SQLite to connect to the database, have a select statement from that table to retrieve information, execute that query, fetch all the rows of data. I'm going to gather all the column names, zip them into objects, make a dictionary out of it. Basically, this function is going to get all the rows of data from the chat completions table in the database. And on a side note, this will all be on my GitHub so that you can use this as well. We're going to call that function, store into a log data variable, convert that to a data frame. We're going to add a total tokens column based on the response. And then for the request, based on the request, we're going to get the content or the chat. And then also for the response, we're also going to get the specific content from the response of the LLM as well. Now let's just run this to look at an example. Here it started the logging session ID that we printed above when we started the logging. We asked it the question of the height of the Sears Tower. It responded that is now known as the Willis Tower and is 1,450 feet tall. Now what we did is there's only one row of data in this database and there's 6 columns total. We have an ID you can't see here, that's what this 0 is. The requests and the responses are pretty long, so we're not seeing everything in the terminal. But at the end, we have the end time and then the total tokens. This is the total tokens, a round trip that it costs for the LLM call. And that's pretty cool. But now let's look at the actual tables with SQLite Browser. All you need to do is go to SQLitebrowser.org and go to the download section and then download the one for your machine. Once you've done that, just simply run it. And then when you come to this screen, you want to click open database, and then here's our logs.database. Now let's just open this up and I'll zoom in so this is a little easier to see, but changing the font size kind of makes this wonky and weird to look at. but it has 5 tables here. We're going to look at the chat completions table. And now you can see all of the columns that it actually stores, which is more than what I showed on the pandas data frames. So we have the session ID that we started with, and that's the one we actually printed out. The full request. So if you use this and you click on it, over on the right-hand side, you can see all the actual JSON that we used. And then in the response, you can see the content here. This is the actual answer we got back from the LLM. And then you can see it, the total tokens was 515. The prompt itself was 488. And then the completion, which was the actual response, was only 27. And then here's the cost is cached, lets you know that was the answer already cached. So if I were to rerun this one more time, I would have another row of data, and instead this value would be 1 for the other row. All right, let's switch gears a little bit and talk about something a little bit more fun and experiment with. And this is going to be a vision agent. Well, what is this? Well, it's basically a vision model or an image to text model that can take an image and then describe it. For instance, if we have this image, which is just something I got online and it's a mitochondria, I believe, we can ask the model to describe it. And the model we're going to use is the GPT vision model. And when we ask it to describe it, we get this output. So let's code this with Autogen and see how it works. All right, well, in your project, go ahead and create a new directory. Let's call it 07-vision. And then we can go ahead and create our main Python file. Actually, I'm going to call it vision this time. And then we're going to create the openai config list. So oai config underscore list.json. Now, the difference with the JSON file is this time we're going to use the GPT-4 Vision Preview model. This is going to help describe images, and then input your API key here. Okay, and here is the code for the vision model. Again, you can just take this from my GitHub. Well, we import Autogen, and then we import a new agent called Multimodal Conversible Agent. And what I have here are 6 different images. Most of these I got from Pixabay, but I just found these on the internet, and I just got their, I just copied their image URL. And then we can use these as variables in our messages. So I have a config list. We get the config list from the JSON file we just created. I make sure that I filter it by getting the vision preview model. And this means it'll also get our API key. We instantiate the multimodal conversible agent, give it a name, and then the LLM config. The only difference here is for the temperature, I set it to 0.5, and then I have a simple user proxy agent. You know, we're not going to execute any code, so I just set code execution config to false. Now for the first example, we're going to have a few. I'm going to say user proxy.initiate chat with the image agent. So that's the same, but for this message, so I have this F here in front of these triple quotes. This allows me to give variables inside of the quotation marks. So I say, can you describe this image in detail? And I have an image tag here, sort of like HTML, so it kind of looks like, and I give it the mitochondria image HTTP URL. Well, let's run this. So right click on Vision, run it, and we'll see what it does. So as you can see here, it says, can you describe this image in detail? You only see this image tag, but it's actually getting the HTTP URL of the image. So it doesn't show it up here, but in the background, it knows what it is. So it's saying this image features a stylized representation of a mitochondria. Perfect. Often referred to as the powerhouse of the cell. Probably the only thing I knew about it. Okay, great. This is a quick, simple example of how it works. Now let's do something a little bit more in depth. Well, what I have here in the second example is I initiate a chat like normal with the image agent, and I say, what is this a picture of, and describe everything in it, and I give it an image of a golden doodle. Then I also send another message. So this is new. You can say user proxy dot send another message to a recipient, and I say, what dog is this a picture of? And this will be an image of a corgi, and which of these dogs tends to bark more, this one or the previous dog image. So it's going to answer all these questions for us when we run this. So go ahead and right click vision.py and click run. So we ask it the first question, which will be the image of the golden doodle, and it'll answer that first. Okay, so we asked it the first image about the golden doodle. So it goes, and image explainer says, hey, this picture of a charming apricot colored puppy with a wavy fluffy coat, likely a poodle or a poodle mix. Well, I know it's a golden doodle. Okay, and there is the image of the golden doodle. Yeah, it kind of has a blue color there. Even in the background, there are a pair of black rubber boots. And, well, they're kind of boots, maybe. I don't know to say they're boots, but either way, it did a pretty good job. And it says, what is this dog a picture of? And this is actually a picture of the corgi. Then we ask which of these dogs tend to bark more. So in here it says the dog is an image of a Welsh corgi, blah, blah, blah. And then regarding to the tendency of the tendency to the bark, it's not possible to determine. So I think it just kind of goes on and says it doesn't really know. Um, but I think it's saying the poodles can maybe be more vocal. But either way, it answered two different questions in just one chat. Okay. And in the final example, I say, what is this a picture of, and describe everything in it. And this is just an image of Luigi, Yoshi, and Mario. And then again, we say user proxy.send, what game is displayed here? And I'll show you what that is after it tells us. And then among all these characters, which has sold the most amount of games. Okay, so let's go ahead and run this and see how it, or see what it tells us. Okay, so first off, let me show you this. This is Luigi, Yoshi, and Mario, and then the second one about the Super Nintendo is this is actually, if you can't really see it, it's supposed to be Donkey Kong Country 2. So let's see what it tells us. So the first one, it says, talks about, okay, it recognizes Luigi, Yoshi, and Mario, and then what game is displayed here, and among all these, which has sold the most amount of games, and can you give me some figures for all characters shown? Okay, so the image displays the Super NES with a cartridge inserted. The game is Donkey Kong Country 2, which is correct. Okay, and then I think it goes on to explain it more. But as regarding game sales, Mario is the character who has sold the most games, given that he's the main character of the Mario franchise. That makes sense. And then so basically it kind of gives some more of that Donkey Kong franchise, tens of millions of units sold with the original Donkey Kong Country for SNES, selling over 9 million alone. Okay, awesome. And this is what the vision agent can do. We can give it images and tell it how we want it to describe it, and it does its best to tell us what the image is. And I think that is awesome. It's really powerful. All right, so we just learned about the vision agent, which is an image to text model, meaning we give it an image and then it describes to us with text what that image was about. Now, if we were to reverse that, that means we do text to image, we would give a prompt as text to the model and it would output an image file for us. Similar to something like Midjourney if you've ever used that before. Well, the thing is, OpenAI has a DALL-E model. Unfortunately, you have to pay for ChatGPT subscription, which is about $20 a month. And if you don't, then you'll get an error saying that you basically don't have access to that model to use it. So what I've done, because I don't pay for that subscription, is I have code in another directory that I'll have with all these other projects that we're doing. I'll have the code for you. If you have a subscription, all you have to do is input your API key and whatever prompt you have. So code's gonna be there for you to use if you want to. However, later on in this course, I'm going to show you how to do it for free using an inference server through Hugging Face. Well, let's go ahead and move on to the next topic. So far, we have been using OpenAI's API, which means we had to spend some amount of money and we had to use their family of models. Well, there is a bigger selection out there, and I am going to show you a way to use an LLM locally using a software called LM Studio. This means we will download a model and start a local server that will allow us to connect that model to AutoGen. And we can use open source LLMs such as Mistral, Gemini, and Llama. The software is called LM Studio, and as of this video, we're going to be at version 0.2.20. How this code and connection will work is we will download LM Studio, find a model in the software to use, download that model, load it into the software, and then finally start a local server. This is all going to be done through the software. One of the pros of LM Studio is it does make it easy. It has a nice user interface. It makes it easy to do all of this. And then finally, we're going to connect all of that by changing just a couple of the configuration properties in AutoGen. Let's download LM Studio, go over it really quick, and then run it with AutoGen. All right, so the first thing we need to do is go to lmstudio.ai. And then once you're here, download LM Studio for your machine. And then once you've done that, just run it. And then this is the home page that you'll be greeted with. Now, what we need to do is download a model. You can choose any model that you want to download. I've already downloaded ones that are small that my computer can handle, but you're more than welcome to either scroll down on the home page. So here, Qwen 1.5, I don't have it downloaded yet. So if I wanted to, I just click this download button, opens up a bar at the bottom. I can open it up, and then you can see that it's starting the download. You can scroll down and choose any of these, or at the top in the middle here is a search bar. You can search for something like Mistral. You click enter, and then on another page, it'll show all the results on Hugging Face for Mistral models. On the left-hand side, you can also go to AI chat, and then you can simply play with your model. You can, at the top here, select a model to load it up. Then once it's loaded, you can just start chatting with it down here. So what we need to do is on the left-hand side, there's this double arrow here. This is for local server. So click that. And now what you can do at the top again is the same, select the model to load, click this and choose a model that you want to use. I'm just going to use the Phi-2 model because it's small for my machine. So I'm going to click this. It's going to start the load process. And whenever that's done, this start server right here, this button will light up green. All you need to do is just click start server. And that's it. Now we can use this model in our agent workflow. Okay, so what we're going to do is create a new directory. So right click on the project and then just name this one 09-lm studio. And then just create a main Python file. I'm not going to use an openai config list this time because I'm just going to show you directly in the main Python file kind of the new configuration you need. Okay, it's going to look a little bit different, but I import Autogen. I just create a main method, which at the very bottom we will use to run. I have an LLM config, which I just named Phi2. I gave it the config list, the cache seed, which I just set to none, and the max tokens. Cache seed set to none. Again, this means that it will not create a cache directory under your directory project. So for the config list, this is a little bit different, right? Because we're not using OpenAI's API key for the first time. For API key, we're just simply putting in lm-studio. For the base URL, we get this from LM Studio. And also for the model name, which you need for this, you also just get that from LM Studio. So if we go back to LM Studio here, like I already mentioned, this is where you get the localhost URL. And then if you scroll down just a little bit, you can get the model name here and just copy and paste that. Now I just have a simple conversible agent, which is the base agent class. I give it a name, LLM config, and the system message that your name is Phil and you're a comedian. I also have a simple user proxy agent. I have a name, the code execution config is set to false, and the human input mode is set to never. Now, when you're using LM Studio, you need to have the default auto reply on any user proxy agent. If you don't have a default auto reply, it will end up failing because there will be it'll look for the content in the chat history. And if it's empty, then it will just fail. So in order to not make this fail, you can just put something here. It doesn't matter. It just has to be something. And then I just say user proxy initiated chat with Phil and tell me a joke. Now let's see if it actually tells me a joke. So right click on main.py and click run. Now what's going to do is whenever the user proxy initiates the chat with Phil to tell me a joke, back in LM Studio, as you can see here, it's actually streaming and accumulating all of the tokens to tell a joke. And whenever this is done here, whenever the streaming is done, it's going to give us the response back in our IDE. Okay, well, I am using the Phi-2 model, and it is a small model. And even though it runs really well on my machine for the machine that I have, it doesn't always give you the best response. So it's saying this is a program for you. I have a joke to tell you today. You see, it's kind of it's giving me an outline for a joke. And that's okay. This was just an exercise to show you how you can download models onto your computer, have a server, and then connect that with Autogen. It means you are not paying anything for OpenAI's API key. And that means you are not paying anything to run this. And that's something that I do like. Okay, the next topic we're going to talk about is called function calling. Now this can be a little bit more advanced, but I know you can do this. So far, we've let agents produce answers and execute the code. But maybe we have user-defined functions that we want these agents to execute. For example, maybe we have a specific currency exchange function, or we want to ensure we always save the last result in the chat history to a file. And just to be clear about function calling, it really is just a Python function. That's all it is. So for example, we could take this reverse string that we created in the very beginning of this tutorial from ChatGPT. We could take this function and put it in the code and then have an agent specifically execute this. So how is function calling going to work with Autogen? Well, in this example, we're just going to have a simple two-agent chat. We're going to have a user agent and the coder, which is just an AI assistant. Now you see some new things here like register for execution and register to LLM. Let me explain. We're going to create a currency converter function. It's just another Python function that we're going to have, and we want these agents to execute it. Well, how we're going to do that is using Python decorators around the Python function. And two of the decorators that we're going to use we'll say coder.register for LLM and user agent.register for execution. What is going to happen, and I'll show you whenever we go to execute all of the code, is that when the user asks a question to the coder is going to suggest a function, and it will be this currency converter to the user agent. And then the user agent will be the actual one to execute that function. And then the coder will get the response, send that back to the user, and then we'll get the output. I know there's kind of a little bit of information, but it might be easier and it might help to explain it if we just go through the code, then we actually execute it and look at the chat history. Okay, well, we have a project. Let's create a new directory as usual, 10-functions, how about function calling? We'll create a main Python file. And then instead of creating another config list JSON, I'm just going to actually copy one from above and then paste it here. Okay, so let's actually code this one together because this is going to be a little bit different than what we've done. So let's just code this together. Well, the first thing is we do have some imports, right? So you have import literal, autogen, and annotated, which I'll show you why we need that. Then we'll say config underscore list equals autogen dot config list from JSON because we created the JSON file. We'll say env or file equals oai config list.json, and then filter dictionary. You don't necessarily have to do this here, so you can omit this, but I just kind of make it a habit for myself. So then we want to filter out by the model, and this is an array, so we're going to say GPT 3.5-turbo. Oh, not E.5, 3.5. Okay. Now that we have that, the next thing is to create the LLM config. So say LLM config equals, we have the properties config list. I'm just going to give it the config list. And then I set the timeout to 120 or 2 minutes. All right, we also only have 2 agents to create, a currency bot and then the user proxy. So let's go ahead and create the currency bot first. So currency underscore bot is equal to autogen dot assistant agent, and that is bot, not cot. Okay, so we have the assistant agent, and we'll say the name is equal to currency underscore bot, the system message. I'll just go ahead and paste this in here. This is basically, we just want for currency exchange task, only use function you've been provided with. Reply terminate when the task is done. And then we need to give it the LLM config. Because it is an assistant agent, we need to provide the LLM config. So LLM config. And then we need to create the user proxy. So user underscore proxy is equal to autogen dot user proxy agent. The name is equal to user underscore proxy. And then we're going to create an is termination message. I'm just going to go and paste this in here. This is just the lambda I'm creating so it knows when to terminate. The human input mode is going to be set to never. Sorry, so that's going to be set to never. The max consecutive auto reply. I'm just giving you some of the properties so you kind of get familiar with them. You can just set this to 5. It doesn't normally doesn't really happen that often. And then we set the code execution config to false. Now here's where we're going to use the literal library. So we're going to say currency symbol. Symbol is equal to literal. Then we're going to have, in this simple example, we're going to have 2 different currency symbols. So USD, and then we're going to have for the euro, EUR. Okay, and now I know I said that we're going to create one function, and you could combine all of this into one function. Actually have 2 separate functions. One is going to call the other. So let's just do it, and this will make sense whenever we're done. So the first one is going to be an exchange rate. So we're going to define an exchange rate function. We need one parameter to be the base currency, and this is going to be the literal, so currency symbol, and then the quote currency. This is going to also be the currency symbol, and then we want this to return a float. Now I'm just going to kind of make up. I know these aren't going to be one-to-one to what it's really like now, but if we say the base currency, this is equal to the quote currency, then these are the same, then we just return the exchange rate is 1.0. However, if the base currency is equal to USD and quote currency is equal to euro, then we're going to return 1 divided by 1.09. And then if the base currency is equal to euro and the quote currency is equal to USD, Then we want to return 1 divided by 1.1. Else, we want to raise a value error saying unknown, unknown currencies. Then we have the variables for base currency and the variable for the quote currency. Okay, so this is just going to be kind of like, I guess, a sub function that's going to be called when we actually have our currency calculator. So let's give this some more space here so you can see what I'm doing. All right, what I'm going to do here, this is going to be the actual function that we talked about in the PowerPoint, and I'm going to just create it first, and then I'm going to give it the decorators. So let's give it some space here. So def currency calculator, because that's what we want to create. And then what we need here is we're going to have 3 different parameters. So we're going to have the base amount. So remember, we're going to be converting currency. So we need a base amount and then the base currency and the quote currency. So the base amount, and what they do for they force you to kind of give a defined type for each of these parameters for function calling. So we're going to say annotated. We're going to give it the type and a little description here. So amount of currency in base currency. Okay, and then we're going to do the same thing for the base and quote currency. So base currency, this is going to be also annotated, and this will be a currency symbol, so either USD or Euro. And this is just the base currency. And by default, this will just be USD if we don't actually give it one. And then the quote currency is going to be annotated as well. This is going to be another of type currency symbol. This is going to be the quote currency. And by default, we will make this euro. And we want this to return a string for the LLM. Okay, awesome. Well, we want to say now is quote amount is going to be equal to the exchange rate. This is the function that we created above. Let me scroll up just a little bit. And we're going to give it the base currency, that's what we need to, and then the quote currency. And then what we're going to do is multiply that by the base amount. This is the amount that we want to see what the currency is in, like from the base currency to the quote currency. Okay, and then we just simply return, let's see, we give this F for format, and then we're going to give it the quote amount and the quote currency. Now, we're not done because we haven't added our decorators like I showed you in the PowerPoint. So the first decorator is going to be user proxy. So this is going to be the user agent that's actually going to execute this function. So you're going to say register for execution. And then we're going to say at currency bot.register for LLM. Okay, and we are almost done. The last thing we need to do is just initiate the chat. So you can say user proxy.initiate chat. You guys are gonna be pros at this by now. So that what we want to do is say the user proxy. Obviously, you want to initiate with the currency bot or the I called it current bot. I'm sorry. Let's scroll back up here just so this makes sense. If you want to do a refactoring of a name, you can do Shift F6 in PyCharm. So they can say currency bot. Okay, cool. Now we renamed it. So we want to initiate the chat with a currency bot. And the message is we're going to say how much is, let's see, $1,234.56 USD to euro. All right. And if you want to, you can highlight over this and reformat the file. And I'm sorry, there is one more thing that I forgot. You had to give a description for the LLM so it knows something about this function. So here in the, when we say currency bot the register for LLM, you'll say description is equal to currency exchange calculator. If not, you will get an error. Okay, now let's try to run this. Okay, so, we want to know how much this was from USD to Euro. So the currency bot, now it's their turn, and they have a suggested tool call called currency calculator. The arguments are the base amount here, the base currency USD, and the quote currency is EUR. Now when we go to actually execute the function, the user proxy is actually executing the function, and the response, this is the float value response in Euro. So now the currency bot is going to say, okay, well, this amount is equivalent to $1,132.62 in euro. Okay, so let's just do that. Let's just see that one more time. The user proxy gave a message to the currency bot. The currency bot said, okay, in order to do this, I have a suggested tool call called currency calculator. Gives it the arguments. The user proxy actually executes it. And then the currency bot says, okay, now that you got the function, you got the result, this is the equivalent or this is the currency exchange. All right, so we just went over function calling and take a slight intermission before we go into the next topic, which will be tools. At the end of the day, whether you say function calling or tools, these are both just user-defined Python functions. But as far as the AutoGen framework goes, there are some slight differences on how they're coded. And at the end, when run tests between function calling and tools with the AutoGen framework, you'll see a couple of the differences whenever I have correct prompts and prompts that have nothing to do with the functions. And we'll see the results of that. You're doing great so far? Let's get into the next video. Okay, so what are tools? Agents writing arbitrary code for us is useful. However, controlling what code an agent writes can be challenging. This is where tools come in. Tools are just predefined Python functions that agents can use. Instead of writing arbitrary code, agents can call tools to perform actions such as searching the web, reading files, or calling remote APIs. You can control what actions an agent can perform. In this example, we ask the assistant agent, what time is it in NYC? Well, the assistant now has two different tools to choose from, get time and get weather, which again are just user-defined Python functions. Let's dive a little deeper into how this works. We still have a user agent that's going to ask what time is it in NYC to the assistant agent. Now the assistant agent is going to say, okay, do I need to use a tool? If the answer is no, then the agent is just going to ask the model the question and then get an output. But if the answer is yes, then the agent can choose either or maybe both of the tools to come up with the answer. But in this case, they're going to choose the get time function or tool, execute the tool, get a response, send it to the model, and then give us an output. So what we're going to do is we're going to run some tests. So we're going to recap the function call test really quick, test the tools with different prompts, and then I'm going to show you the differences through the AutoGen framework. And then we'll see what happens when we purposefully give prompts that aren't related to any of the function calls or the tools, and you'll see the difference between them. Okay, so let's go ahead and start coding. Let's create a new directory under our project. This will be 11-tools. And then let's go ahead and create a main Python file, or actually we can just call this tools. Okay, so the first thing we need to do is have our imports. We'll import AutoGen and then annotated again, because we need that for the tools, just like we did function calls, and then we're import date time. So now we're gonna start creating our tools. And the first one is called get weather. Remember we had a get weather and get time. So I'm going to have a parameter called location. It's going to be a string. And then this is just a simple description of the parameter. And I'm not going to actually call an API, right? This is just an example. So if the location that's given is Florida, say it's hot in Florida, else if it's Maine, say it's cold in Maine, else just say, I don't know this place. And then we have the get time. Well, here we're going to take a time zone, which is just a string. We're going to get the date time now with the library that we imported. And this is just a way to get the current time. And then we're just going to return the string. So those are our two tools that we're going to be using and registering to our assistant agent. Let's go ahead and create our agent, and let's begin with the assistant agent. So we have the name for the assistant agent. We say you are a helpful AI assistant, return terminate when the task is done. This is actually a helpful portion of the system message. And then for the LLM config, we just have this, I have all this information inline, so you don't have to create a separate file for this part of the project. So I have the model. Actually, I don't really want to use it. I want to use 3.5 turbo. I was playing around with different models, so we're going to just use 3.5 turbo, and then you can use input your API key here. Okay, and now we're going to create the user agent. So we're going to give the name user, give it a termination message so it knows when to look for the word terminate from the assistant agent, and then human input mode is never. We don't really want to intervene this time. Okay, and then the next thing that we need to do is register the tools with the assistant agent. So we're going to say assistant.register for LLM, similar to the function calling. We're going to give it a name. So I'm just going to give it the name of the function. You can give it something different. So I'm going to say get weather and then the description. And the description is helpful. This is going to help give or let the assistant know that this is the correct tool for what we want to use. So giving it a good description will help. And then finally, you need to say in these parentheses, the name, actual name of the Python function that we created. So we're going to do the same thing for the get time method as well. And then we need to register the tool functions with the user proxy agent, because the user proxy agent is going to execute these tools for us. So we're going to say user proxy.register for execution. Just give it the name. You can just give it the function name because we also have in the same thing in parentheses, say give it the actual Python function for get weather and also get time. And then the last thing is we need to initiate the chat. So we're going to say user proxy dot initiate chat. We want to initiate the chat with the assistant, and the message is going to be we'll do the first one, what we did in the PowerPoint. So what is the time in New York City? Okay, now let's go ahead and run this and see what we get. Okay, so it ran pretty quickly. The prompt was, what is the time in New York City? So the assistant said to the user, hey, I have a tool, I want to use a tool, and I have a suggested one that we can use called get time. And we had the parameter as it gives the time zone for America slash New York based on the city that I gave it. So then the user agent is going to execute the function tool, and here is the response. The current time in your time zone, which is America slash New York, is, well, I ran this on the late at night on the 24th. So it went back to the assistant. The assistant said the current time in New York City is 9:54 p.m. And then that's the response. So we're done. Okay, great, that worked. But now what I want to do is I want to give it two questions, and I want to say, what is the weather like in Florida? And this time, what is the time in Paris? So when we go to run this, what it should do is it should use or execute both of the tools that we gave it. Let's see if it does. Okay, so here's the prompt. The first suggested tool call was the get weather, and the argument was, or the parameter was, location is Florida. So the user executed it, returned that back to the user. So it's saying it's hot in Florida. Then the assistant said, hey, the suggested tool call this time is get time, with the time zone being Europe slash Paris. And then the user executed it, and this is the time zone in Europe slash Paris. So then the model concatenates both of them, saying the weather in Florida is hot, and the current time in Paris is, well, it's actually just about the same time. I didn't actually write code to give the exact time based on the time zone, the exact time. This is actually still my time zone. That's okay. I don't live in Paris. And then we terminated and we're done. Okay, great. We have examples of it using a single tool, and now we have an example of using it multiple tools. Okay, now I said that I would go back to function calls and do that test so you can have an idea what that's doing. So let's do that really quick. So if we remember, I had this simple example where we said, for the function call. So let me go ahead and run this. Where this was the currency converter. We had the prompt here. The currency bot, or the assistant agents, gave the suggested tool call. You see, it still actually just says it's a tool call here. Currency calculator gave all the arguments. The user proxy executed it. The currency bot gave that back to the user, and we're finished with the chat. So as you can see, that doesn't really look to me either like there's really any difference between function calling and tools, at least as far as the AutoGen framework is concerned. However, now what I want to do is give these prompts that have nothing to do with the function. And we'll first actually do this with the function calling. So this is a currency converter. What if I say, can you give me the answer to 2 plus 2? Okay, something super simple, right? It's a currency converter, but this is just a simple math problem. Let's run this and see what it does. And look what it's doing. It kind of repeated itself a few times, but I gave it the prompt and it said, I can help you with currency exchange tasks. Let me know if you have any currency exchange calculations to perform. And it didn't actually give me the answer to 2 plus 2. Now, let's do the same thing with the tool. So let's come in here and let's modify this and say, what is, oh, no, actually, let me just copy this so that there are no variants. So what, can you give me the answer to 2 plus 2? Now, let's run this one and see what happens here. Okay, well, so what happened here was that the AI assistant decided that it didn't need to use tools, or that there were no available tools to answer this question. So it just instead went directly to the model to answer the question. So the user went to the assistant. The assistant said, okay, well, the answer to 2 plus 2 is 4, and that's it. We're done. So it still answered it, but with the tools, that gives us the possibility to do something a little bit more specific. It's kind of generalized, but you know, if you have something that's like, hey, I need to save this to a file, or I need to save this to SQL, and I don't necessarily want the assistant to come up with code to maybe a database that already exists, right? So I know that this exists. I just want to do this. Here's a tool that if I ask it to do something, it could do it. Also, just something that I wanted to also point out that I found was in OpenAI's API, and I kind of just just looking around that for function calling, they've actually deprecated this in favor of tool choice. So if you go up here for tools or tool choice, this is what they prefer that they prefer us to use now. So I hope this helped you understand what tools are. All right, so for this video, this isn't exactly AutoGen related, but this is going to be a part of the next little project that we're going to be doing. And we're going to be creating images. However, like I said before, with DALL-E 3, that costs some money. So we're not going to be using DALL-E 3 because you have to pay for the $20 per month with the ChatGPT subscription. I don't want to do that. You probably don't want to do that. If you do, I gave you the code already. But instead, I want to introduce you to something called Hugging Face. If you had not been here, they have over right now, actually, right now, they have 620,000 models. Okay. And on the left hand side here, they have all these different types of models listed out for you. So they have text to image, image to text, image to 3D, text to 3D, text to video, translation, text to speech. They have so many. And what we're going to be focused on is I'm going to show you something and you're going to learn about inference servers. So when you come here to huggingface.co/models, just choose the text to image. And now it's going to filter out by all the text to image models. And the one that we're going to use today is the Stable Diffusion XL Base 1.0. And so not only is it about having the subscription to ChatGPT, but running something like a text to image model locally is taxing on your hardware. And if you don't have the hardware to run it, it is going to take a really long time. You'll be better off to use a service like RunPod, rent out a server, and then, give all the Python code there, create the files, and then run the text to image model. However, I want to introduce you to another way. When you're here, you can choose the deploy at the top right, then choose inference API serverless. If you don't know what this is, first off, inference is basically the whole round trip from the prompt to the completion. That's called inference. You can just send a request to them and they'll give you back the response. In this case, you're going to send a text request to them through a post request, and then they're going to give you back an image. And they actually give you all the code here that you need to do it. So all we're going to do in this video is simply copy paste this and run it so you just can see how it works. So if you don't already, you will just need to sign up, but it is free. Then you just need to copy this. We're going to create a new directory. So create new directory. We'll call this 12 and say text to image. Create a new Python file and then just copy and paste everything. And it even gave me my bearer token for authorization. Okay, and all I'm going to do here is after I formatted the code, I'm just going to add one line here, image.save, and then just give it a file name so it saves it locally. So all we're going to do now, I'm just going to simply run this. So I'm just going to run this. It finishes. I minimize the terminal, and here we are. We have a test.png, and here is our astronaut riding a horse. It is that simple. And if I were to do this on my machine, this would take so long if my, machine didn't crash before it finished. And this is something called an inference server. Of course, this was free. They do have dedicated servers that, you might want to use for production, but this was free just for us to use for development. Okay, so for this next project, what I want you to do is I want you to create a main Python file, create the config list like we have been, create a user and an assistant agent. I want you to create a tool called create image, register this tool correctly, like I showed in the video. The tool should create an image from the inference server on Hugging Face like I showed you. Save it to local and be creative. Go ahead and pause the video, try this out, and whenever you're done, replay the video and I'll show you how I did it. Okay, great job if you got, or even if you just got something working, great job even for trying. If you weren't able to, here I'm going to go through what I did. So I have my API URL and the headers. This was kind of the main thing. So I created a tool called create image, had the response and the image bytes. This is kind of exactly what we did before. Really isn't anything different. I have a random number and a file name. This just gives me a random file name, which I'll show you over here so that I can run this and I don't have to rechange the file name or won't overwrite. Then I have the image open and then I finally save that and just return the message that we were given. The tools here tend to complain if you tried to like not return anything because you don't really need to. It'll kind of complain, so I just have it return the message so the warning isn't there. And then I have the LLM config, an assistant agent, and the user proxy agent. And then finally, I registered for the assistant agent, I registered for LLM, the create image function. And then for the user proxy agent, I registered the same create image function registered for execution. And then I said user proxy.initiate chat, create an image of a professional football player. Now I said football, I even spelled it like I know internationally football, here in the States, soccer. So whenever I did that, I got this, but this is an actual American football player. His hand is kind of morphed into the actual ball here, and I'm not sure really what's going with his mask up here, but not a bad image. So I hope you learned something from that, and I hope you're able to get something working, just trying and doing some repetition. It'll help you get used to how the multi-agent framework works. Today, we're going to be using Reddit to create a newsletter. This will be done using the Reddit loader from LangChain, and then AutoGen will orchestrate the agents to create the newsletter. The first thing I want to show you how to do is just go to Reddit and create a simple app from your user so that we can get an ID and a secret to use for the Reddit loader, and we can get whatever subreddit and the post from there that we want. All right, well, the first thing is this URL will be in the description. You come here, there will be a button if you haven't done this before to create a new app. You click on it. You want to give this information in here, right? So I gave it the name, Tyler-newsletter. You choose the radio button for script. You can just put reddit.com's URL in here, and then you click I'm not a robot. And when you click create app, it'll say application created, and you'll be given your client ID here and your client secret here. And this is what we're going to use inside the Reddit loader. So you just want to copy and paste those things when we get there. Okay, well, we might as well just dive into the code. So again, like I said, you need your client ID and secret. I'm going to paste my client ID here and then my client secret here. Okay, so we take from LangChain, the document loader, we take the Reddit post loader. We have a user agent, which I think you can name this whatever you want, but I kind of follow the convention that they have extractor by, and then this is my Reddit username. Now you know it. You can give categories here. So I think they only allow you to do controversial, hot, new, rising, and top. So I'm just going to put new. I just want to retrieve posts from subreddits. And then queries here, you can put a list of subreddits that you want. And then you can also put the number of posts from, I think it's from each of these that you would like to have. So then we say documents equals loader.load. So it's going to load all of that information into these documents. We have the config list and the LLM config. I will have it so that you can set up using Ollama, LM Studio, or if you want to use OpenAI's API, that'll all be in the JSON configuration. Then I have two agents. I have the writer agent, which I just want to say, don't change the information you're given, just parse the page content from the Reddit post. No code will be written. If I give it kind of a basic writer prompt, it'll take the information from the post and try to morph it into something else. And I don't want that. I just want the information from the post. And then we have a standard user proxy agent. And now we want to initiate the chat. So it's just a simple user proxy initiating chat with the writer. I want to extract the page content and URL from each of the documents from above. So in case you had more than one document, right, there's going to be lots of page contents from each of the documents. And then I just give it some information to separate it out. I want to create a newsletter with the newsletter title here, make sure it's catchy, and then a format of the markdown here. And it's just going to print this out for us. This is going to be a simple example to show you how to use Reddit to get, it's not, I mean, it's simple, but it does give you a lot of information, right? You can search for any AI related subreddit and then get the latest post from there. Let's run this. Let me delete the cache and rerun this. Okay, so it finished. Here is the user chatting with the writer, and then the writer talks back and says, okay, here's the content parsed and formatted markdown ready for a newsletter. So it looks like it kind of has a title, and I want to do 3 posts on OpenAI. So here are 3 different posts, and these are, I set it to be the newest one. So as of now, this one I think was like maybe 40 minutes ago. So let's click on one of these. Let's click on number 2, suggestion for updated laws of robotics by Samuel. So if I open it up, that is by him. It was actually this one was 28 minutes ago. And here is the full description. So if it was a newsletter, it gives part of it and then says read more here, and you can click on the link to read the rest of it. Here I just copied and pasted it into a reddit.md file for markdown. And here's actually what it looks like formatted, which looks nice, right? So it has each one here and then it has the author, and then you can choose, it creates a link for you to read more about it. I didn't even do a whole lot with the prompt. I just created a kind of a simple outline for what I wanted the newsletter to look like, and it created this for me, which is pretty cool. All right, you just finished the course, and thank you for watching. I hope you were able to learn something, especially if this was your first time working with a multi-agent framework or working with AI agents in general. I'll have references to everything that you need down in the description below. Now, the thing is, especially with AI right now, things are changing at a very rapid pace. So depending on when you see this, if something doesn't work, please leave a comment in the section saying, hey, this, what I'm trying isn't quite working, and I'm trying to update my GitHub repositories with all the new changes and updates that are happening almost every other week, but I can always miss something. Anyways, thank you for watching. Please subscribe, like, and comment. I'll see you next video.